Let us get started with the Stateflow modeling environment to build and simulate decision-making systems. There are two components we will use in this example: the library browser and the Stateflow editor. You can open the library browser by clicking the library icon in Simulink. In the Stateflow block library, there are blocks to model state diagrams, state transition tables, and truth tables. There are two blocks for modeling state diagrams. One uses C syntax and the other uses MATLAB syntax for defining comments and commands. For this demonstration, we will use the C syntax. To build a state diagram, drag the Stateflow chart block into the Simulink editor. Let us build a state diagram that switches between two states based on the value of an input u. For this demonstration, I added the sine wave and scope blocks from the Simulink block library. Double-click on the block to open the Stateflow editor. In this editor, you build state machines by dragging graphical objects like states and junctions from the graphical palette on the left. In our example, drag the state object and change its name to on. Similarly, create another state object, off. The system should transition from state on to off when the value of the input u becomes less than 0. In Stateflow, you model transitions between states by connecting them with the transition object. This transition should be taken when u is less than 0. Define the condition for transition execution within square brackets. Similarly, draw a transition object from the state off to on, which is active when u is greater than 0. Place a default transition onto the state on to define which state the system should start in. To perform actions in a state, you can type commands in the states directly. In our example, we will send an output of 1 to Simulink when the system enters the state on, and send an output of -1 when it enters off. Run the state machine. The symbol wizard identifies variables used in the diagram and suggests their scope based on usage. In our example, since u is only being read from, it is suggested as an input. Similarly, since y is only being written to, it is guessed as an output. I can of course change the scope of these variables if needed. Notice that in the Simulink editor, the chart block now has an input u and an output y. Connect the Stateflow block with a sine wave and a scope. You are now ready to execute your state machine and visualize its response to the input.